Now let's look at the second and preferred solution to solving our computer science challenge, which was to reverse the words in a given string. The solution is motivated by the fact that we wanted to get rid of the extra buffer or memory allocation in the first solution. Remember, we had to allocate new memory in our solution? We don't want to do that, because if the string was really large, then we'd have to allocate just as much memory, extra memory, so that we could solve it using the first solution. We want to get rid of that requirement. And what we want to do is be able to perform this reversal within the same string. How are we going to do that? I'll give you an example right here. The algorithm is in fact a pretty elegant algorithm and consists of two sets of reversals. So suppose this was our string, first, second, third, so these are three words, and this was our string. What we're going to do, the first step, so I said it consists of two sets of reversal. The first reversal consists of reversing all the characters in the string with no concern as to in which word they are located. So it's a very simple reversal. We take the first character and swap it with the last character. Second character, swap it with the second to last, and so on and so forth. So we get something like this. We get the period comes here, and the F, which was at the beginning, goes to the end. D is swapped with I, so D comes right here, I right here, and so on and so forth. So you get this word in its reverse order. So you get period D R I H T space, and then D N O C E S space, and then T S R IF. So essentially this is the first reversal. We're just swapping the corresponding characters right here. Once you did this first reversal of the entire string, you notice that you've actually placed the words in their reverse order. So you have third right here, second right here, and first right here. And this is exactly what the challenge is asking us to do, except we have the characters reversed. In every word, the characters are in their backwards position. So what we're going to do is perform another set of reversal, but this time it's going to be applied over every single word. We're going to swap T and the period here, H and D, I and R, similarly for second and first. And this way, so this is our second set of reversals, we're going to bring T here, H, I, R, D, period, and then swap S and D, E and N, C and O, so you get second here, and then perform another reversal here for this word, and you get first, F-I-R-S-T. And there you have it. This is this is the solution to the problem. So we see that we've essentially performed two reversals. There's this reversal, and then there's this reversal applied to every single word, so we get its characters in the proper order. The first reversal is to place the words in their reversed order. So third comes here, second comes right here, and first comes right here. And then the second reversal is to get the words having their characters in their proper places. And this algorithm is really easy to remember, because all you have to remember essentially is that you have two reverse steps. So if this problem comes up in the future, and like I said, it's a very common problem to reverse the words in a given string, just remember reverse, reverse. First you reverse all the characters in the string, and then you reverse every single word in the string. And for that, actually, to implement this algorithm, we're going to see we need a reverse method. We're going to have to write a reverse function that does these swaps. So we pass it the beginning of a particular string and at the end of it, and then we let it perform that swap over the characters in that string. Now let's look at the time and space complexity of that algorithm. The time complexity, we have two steps. The first step is to reverse all the characters in the string, and if you look at here, suppose this was our string, we perform 1 swap, 2, 3, 4, and so on and so forth, and you notice it's n over 2, and this is a big O of n. So we have less than n swaps. So if we have n characters, we will have around n over 2 swaps. So it's a big O of n. This first step is a big O of n. And to reverse every single word in the string, so we're going to look at subsets of the string and perform the same swaps. At this point, actually right here, perform swaps over the characters of every single word so that we place them in their correct order. Then this also is a maximum of n steps. So we'll actually have less than n over 2. Because here, for example, we had 1, 2, 3, 4, 5, 6. How many swaps are required? 3 swaps, and so on and so forth. So at this point, we also have less than n steps, so it's also going to be a big O of n. So this is big O of n, this is big O of n, and big O of n plus big O of n is, of course, big O of n. So we know that the time complexity of this algorithm grows with n, and this is pretty good. Now, in terms of the space requirement, in the other algorithm we had a big O of n. This one, the second solution, will be a big O of 1 because it's independent of the number of characters we have in the string. We will not allocate new memory as we did in the first solution where we had to create a new buffer. We're not going to do that. We're just going to use the same string and perform our swaps within that same string. So it's big O of 1. So this is the time and space complexity of our solution. Now let's move on to implementing it in code. So the first thing I do here is I include some libraries that I'm going to use, and then here is my reverse function. This is a utility function. This is a function that I'm writing so that I can use it within my other main function that I'm writing to solve the challenge. This was the function prototype specified to us, if you remember. And this is one that I'm writing just for my benefit. I could have put it inside, but just for my benefit because I'll be calling it over and over again. And I know that I'm performing multiple reverses, one for the entire string and then for every single word in the string. So I'm going to write this reverse function. What I'm going to be passing it, I'm passing it the start index and the end index of a particular string that I'm passing right here, and what it's going to do is it's going to perform the reverse of those characters within that string from the start to the end. This is going to help us for the entire string and for every single word in the string. And how do I do that? I use a temporary variable, a character right here, and then I say while start is less than end. So start is going to be, suppose I wanted to reverse a particular word, start should be pointing here, end should be pointing here, and while start is less than end, what I'm going to do is I'm going to assign the character in start to the temporary variable, so store that character in a temporary variable, and then take the character in end, copy it to the start, and then finally take that temporary and put it to end. So essentially I'm performing a swap here, and this is how you perform a swap in C, just to remember that. So when you perform a swap in C, there's no easier way. You need a temporary variable, and you store one of the characters in that temporary variable, you overwrite that character, and then you take that character from the temp variable and you rewrite it to the other position. So this is how we do it, and then what I'm going to do here is just increment start and decrement end, and keep on doing this until start is greater than end. That is, they cross one another, and that means that I've essentially performed the swap for every single character in that string that we're looking at. So this is my reverse utility method or function that I'm going to be using in my original or my main function that I'm writing here. So this is the function to solve the problem that the user will be calling to reverse the character or the words in the string. The first thing I do is I'm going to have an I integer which will go over every single character in the string, and it will start at 0, so it'll go in this direction. And then I'll have a start index or pointer, and this will store the index of the first character in a particular word, and we'll see how we use these. And then L, just like we had in the first solution, this will store the length of the string. The first step that we do, this is our first reverse. If you remember from the algorithm we looked at, this is reversing the entire string. So we go from 0, the beginning of the string, to the end of the string, and the string goes from 0 to L minus 1 when its length is L. And this is the string that I'm passing, that was passed to us. And this reverse is just calling the function that I just wrote, and it's essentially going to perform the first swappage. So it's going to swap that character with that character, this character with that character, and so on and so forth, until at the end we will have all the characters reversed, and this will give us the words in their proper order but having their characters in reverse order, and we'll rectify that in the second step. So this is the first step, the first reverse, and this is where we perform then reverse every single word in the string. This is our second reverse. How are we going to do that? We have it right here. We're going to have a while loop that goes from I to the end of the string. I is 0, remember we set it to 0, so we're going to go from the beginning till the very end of the string. I is equal to 0, and L is right here, so it's going to be I less than L, so it's going to stop right here. So we're going from the first character to the very end, and what we're going to do is we're going to set start to I, so we're going to start right here. This is our first word, set start to the first word. And then what I'm going to do is I'm going to increment I until I find a space character or the null or terminating character here. So I'm going to increment I until I find a space. Suppose this was a word here and we have another word and we had a space here, so I will be incremented until it gets to this point right here, the space. And then what I'm going to do is I'm going to perform a reversal over that word that I just found here, because I encountered a space, and when I encounter a space I know that I just went beyond that word that I was looking at, so my ending will be I minus 1. I will be pointing at the space, I minus 1 will be the last character of that word. This will be my end, so I'm going to pass it as being the end, and I have start, I kept it in memory, remember here? This is the start of the word, and I am passing the string. So this is to reverse a particular word in the string, and then when this reversal is complete, this is taken care of by the method or the function that we wrote earlier. And then what I'm going to do is I will advance index I to the start of the next word. So if we have multiple spaces here, just keep on incrementing I until you reach the beginning of the next word. So let me just delete that. Suppose these were all spaces. We had our next word right here. So I will be incremented until it reaches the next word. The function will come back right here, and we do the process again. We assign start to the start of the next word, and then we increment I until we reach the end. So I will be incremented to the end until we reach the end character of that second word we're looking at, and then we perform a reversal over that word, and so on and so forth until we reverse all the characters of every single word. And then in the end, after performing the first reversal here and these sets of reversals, we will have the string with the order of the words in their reverse order in the string.